Today I'm going to introduce you to the world of blockchain. So I'm going to present what blockchain is from a cryptographic perspective, since my background is in cryptography. A few words about the Cyprus Blockchain Technologies. It's a non-profit organization that we have established very recently, and we have many members joining this consortium, like all the major banks and big universities like University of Nicosia, CIIM, UCL, and technology companies like Oracle. We are always interested for more members if they would like to join our consortium. And if you would like more information, you can visit our website. The presentation overview for today, firstly, we're going to do the maths behind the blockchain. So I'm going to do a fair introduction to the blockchain work from a crypto perspective. Then we will spend some time to understand what are public and private blockchain, as well as some consensus algorithms. And lastly, we will touch a bit the world of smart contracts and initial coin offerings. Any of you who know about ICOs? Heard about the ICOs? Very good. Thank you. Okay, so what is blockchain technology? It was firstly introduced in 2008 by someone called Satoshi Nakamoto. Nobody knows. There are many speculations around, maybe secret services or any other countries. Nobody really knows who was Satoshi. And we have this fundamental paper called Bitcoin, a peer-to-peer electronic cash system. This is like the seminal paper that describes, in a nutshell, how blockchain works. A year later, we have this Bitcoin ecosystem becoming like an open source. We have many developers started developing a proof of concept about Bitcoin, and then in 2009, it became a reality. Why Bitcoin is very, very popular and why it's very respectful at the moment is because it's the first complete e-cash system that has been developed. Researchers have been working to build an e-cash system since 1985. We had many attempts to solve these problems, and Bitcoin was the first mature enough e-cash system that has been introduced. And what it is, it's a peer-to-peer network in which users can transact in a pseudo-anonymous way. You don't have full anonymity, as it is claimed, because you are linked with some piece of data which is the public key. So you can join this network in a pseudo-anonymous way, and there is no central authority or intermediaries responsible for overseeing the transaction. The way things are being valid, are proved, is through the encoding of the system, in which we have rules and incentives being hard-coded into the software, actually, into the nodes. And the idea is that always the majority wins. When you would like to approve a transaction over this network, these transactions, as we are going to see, is relayed over the network, and then the whole network needs to work towards approving the transaction. So there is no central authority. And the other spectacular thing is that all data are public. Each member of this network, each node of the network, can maintain and store the ledger. What is a ledger? It's a database that contains all transactions. What does this mean? You have full transparency, since in real time you have access to all transactional data, and you can view them anytime. And Bitcoin and blockchain is like the celebration of cryptography. We have all smart technologies from the crypto world, like digital signatures, hash functions, PK infrastructure, public key infrastructure, all being glued together in a very elegant way to form an e-cash system. Problems that have been addressed in Bitcoin ecosystem that were very, very important and allowed to have a full technology that allows you to transact without any central authority are these three. No counterfeiting, nobody can increase the money or any other asset supply at will. Everything is fixed there and controlled by the network. No double spending. This is like a problem that researchers were trying to solve since the 1980s. Nobody can spend the same value more than once. It's not like the paper case in which you have like identifiers, you have a physical copy, you can only spend it once. In the digital world, things are much more difficult to control. So double spending, it was addressed in the Bitcoin architecture. And also transaction irreversibility or immutability. When something is approved, you cannot really change it. In other words, the only way to change things on the blockchain is to have enough computing power like the atoms of the universe. It's impossible to do it. Okay, this is about Bitcoin and what is blockchain. Blockchain is the database behind Bitcoin. So it's a shared, distributed, append-only, cryptographically secure database or ledger that is used to record the transactions happening in the network or any other actions. It's not about transferring money. You can set up any other things that you would like to be recorded over the network. Maybe access to some servers or request for access to some servers. And ownership of an asset in this network is guaranteed through digital signatures, public key cryptography. What does this mean? Ownership of an asset or the right to perform a given action, if we are talking about private blockchains as we are going to see, is guaranteed through your private key. If you don't have this private key, you cannot really do anything. You cannot claim that you own something. You cannot do any transaction. And the only way to append on the ledger is the whole network to come into consensus to approve your transaction, as we are going to see, in case of a public blockchain, or in case of a private blockchain, your transaction has to be approved by the relevant nodes given some hierarchy that they have. And it is claimed that blockchain will do for transactions what internet did for the internet. And even though we know that it's overhyped, like all technologies, when they appear, they are overhyped. Everything believes that all problems will be solved. This is not the case. Some problems only will be solved with blockchain. Some characteristics of blockchain technology: decentralized, peer-to-peer network. No central authority is needed to oversee transactions. The power is given to the nodes of the network. Distributed ledger. All participants maintain a copy of this ledger. You can go and download a client of any cryptocurrency that you are interested in, and you can see that you have the option to actually store all the transactions. Immutable, we have some very strong cryptographic functions called hash functions that we are going to see that are used to make the transactions resistant to modification. Transparent, everything is public in this ecosystem, and every node maintains such a ledger. And smart contracts, you can set up smart contracts in this environment. According to Harvard Business Review, the technology most likely to change the next decade of business is not the social web or big data or cloud or robotics or AI, but it's blockchain. It's supposed to be the most well-celebrated technology at the moment. And that's why we have a very big community working towards blockchain innovation. And in the last 3 years, we had more than 2,500 patents being filed regarding blockchain. And based on some research by Gartner, we have the statistics that like $176 billion as value will be added to business that utilize blockchain technology in the future. Use cases for blockchain technology: you can use it for storage of digital records. This is what the University of Nicosia is doing with their degrees at the moment. Exchange and tracking of digital or physical assets, like the tokenization aspect. When you really buy a Bitcoin, it's like transacting some unique values, some values. Crowdfunding, you can use blockchain in order to do a crowdfunding campaign and raise money required for your startup or your enterprise to, for example, release another product or do further enhancements to their current products. Through initial coin offerings, as we are going to see, you can have 3 types of tokens offered: utilities, securities, and currencies. Later in the slides, we're going to spend more time on these 3 to understand what they are. And another very important use case that appeared with the appearance of Ethereum blockchain is the execution of smart contracts. What is a smart contract? It's a set of agreements. What is an agreement? You have some conditions and you have some outcomes that need to be observed when these conditions are met. And we do this in an algorithmic way. This is like a smart contract. This is how blockchain technology works in a nutshell. Let's say I'm into the Bitcoin network or any other network, and I would like to send some of my Bitcoins to some other person. Firstly, I need to prove the ownership of these Bitcoins, of these tokens. This is through my private key, which means I can unlock my wallet, for example. Let's say I do this, and I would like to transfer X amount of Bitcoins to another party. This message, I would like to transfer this amount of money to this person, is relayed over the network. And the miners need to start working towards verification of the transaction. They check if you have enough balance, if this has not been spent again. And after some time intervals, we have all the transactions being populated in one block. What's the next step? Is to verify this block so that all the miners start working towards verification of the block and appending this block to historic data. And the way the append operation is done is in a way such that if you would like to modify any transactions, either at this level or at any level, you have to go back and change all transactional history, which is impossible to do unless you have the power of all the secret services in the world. All transactions are visible. You can go, for example, on blogexplorer.com, and you can see transactions happening at any height on the blockchain, or on the Bitcoin blockchain. And you can see identifiers of each transaction. You can click on this, and you can see from which public address to which public address this transfer is taking place. Why blockchain seems to be important? It solves one major problem. Imagine a scenario in which you have many participants that need to communicate for solving a particular problem. Or, for example, supply chain example. You would like 4 participants to exchange communication in order for something to be delivered. That means, in a traditional way, each party has a database which they need to maintain and update all the time, and they need to relay messages to the other participants of the network. This is of quadratic complexity in terms of communication. What means quadratic? It means that each pair have to communicate each time in order to update the status of what is happening. If you use blockchain technology, you can actually linearize this by having all the nodes running like the blockchain, and automatically in real time populate information on this ledger, which is accessible by everyone. So blockchain revolutionizes the traditional business since it makes this most cost-effective, efficient, and more secure and safe. From a crypto perspective, how blockchain works, ownership is guaranteed by public key cryptography, digital signatures. If you lose this private key, secret key, then you are out. You don't really claim your assets. And each user has 2 pairs of keys. One is the public and one the private. The public one is used as a piece of information in order to derive an address for you, so that you are identified over the network. That's why you don't have full anonymity. It's pseudo-anonymity. And the private key can only be used to prove that the user has the access to perform a transaction or access a given service. Addresses looks like this, if you go and check, for example, the Bitcoin blockchain. And how blockchain works: firstly, you use your private key in order to initiate the transaction. The transaction gets an identifier that binds who I am, to whom I'm going to send my assets, and what is the amount I would like to send. So this identifier is a derivative of this information. And the whole idea is that we would like this identifier of the transaction to compute it in a way such that if this is appended on the ledger, you cannot really create another transaction with different transactional data that gives the same identifier. Which means if you achieve this, you cannot falsify any transaction. And this is achieved through hash functions. Any of you who know what is a hash function? Yeah. Okay, so hash function is one-way function, functions like this, in which you give them input that you want and you get an identifier of fixed value. And the brilliant thing about this function is that if you give different inputs, you will always get completely random outputs, which means that if you pass transactional data into this function and get an identifier, it's very unlikely that you will manage to construct another input set, another set of transactional data that will give the same identifier. What does this mean? All transactions are being very unique. Nobody can falsify the transactions over this network. And when transactions are populated in one block, we have the whole set of miners working towards verification. So they do very clever things. They try to compute characteristics of the transactions in order to come up with a difficulty statement. What is difficulty statement? It's a string of data that proves that the whole network did through verification of the process. And in particular in Bitcoin architecture, how this happens, all the network needs to work, and someone at random will be in position to verify the transaction. Why randomness is very important? Because it means next time someone else will get the solution, which means it's like a full democratic way of validating transactions. And if you go on the Bitcoin blockchain, you will see that for each block, you have several metadata, timestamp, the time being approved, the hash of the previous block as a reference, because you would like to link all historic data at the current block with all the data that are historic data. At least one transaction, a Merkle root tree, which is like an identifier that, which is like a data structure that contains all the transaction in the hashed form, the block's own hash, and the difficulty statement. This is like the stamp by the miners that the work has been done and everything is approved. So this is how proof of work actually works, which means that the network has to come up with a string, with an identifier that actually glues all transactional data of the current block with the previous one. And since we know that these hash functions are one way, and when it's found, this solution is found, it's very hard to find another one. So that's being valid. And this is how the blockchain looks like. It's like a hash chain. At each block, we have all the transactions being linked to the previous one, which means that if I would like to change something here, current block, I have to change something here, which means I have to change something here, which means I will never be in position to do it, unless I'm going to live 10 to the 10 years. Problems that we have, because the network is peer-to-peer, there is no single truth. It means that we have some cases like this. We have blocks being validated, but we have some other blocks in this case, like forks. But because we have the whole community working on this, we have all the nodes working to approve the data, this will converge actually to the usual one. Also, we have soft forks versus hard forks. Soft fork is a forward-compatible change to the consensus rules, which means that the whole community said, OK, the blockchain that we maintain and we verify follows some old rules. Now, all of us need to agree a new set of rules, and how this happened, they abandon this, they update the previous rules, and they maintain a new chain. But you can have also hard forks, in which you can have many chains growing in parallel, and this is actually how you derive most of the tokens nowadays. So you can have a blockchain following old rules, and you can derive other chains following new rules. And for if you know Bitcoin Cash, Bitcoin Cash is an example, like we have the Bitcoin and the Bitcoin Cash, that's a hard fork. And ERC20 tokens on the Ethereum stack. This is how it works. Where do we store these tokens? As you know, it can be either in cold or hot wallets. If you have it in cold wallets, it means that the private key is not connected to the network. Maybe you have it on the hardware device. Hot wallets mean that the private key that you have is connected to a device that is connected over the network. Okay, and it's more secure to use cold wallets. So all this about public blockchains. We have also private blockchains. In public blockchains, everybody can enter the network. In private blockchain, it's only by invitation. It's only by the members of the consortium that they might grant some access to you to enter the blockchain. In public blockchains, we have this proof of work concept in order to validate transactions, which means that the nodes need to spend a lot of energy, a lot of time to validate transactions. In private blockchain, you have more computationally intensive operations taking place. You have hierarchy on your nodes, you know your hierarchies, you can impose some access control there, and based on this access control, you can approve or not approving any transactions. So this is how it works nowadays with permission and permissionless blockchains, public ones. Nobody is validating the transactions. I mean, no third party, no liability. You have the whole network working towards this. While in federated or private ones, you have control over the members of the consortium. Examples, public is Bitcoin and Ethereum. It's the most popular one. The problem is that with public blockchains, we have transactional limitations, like 7 to 15 per second, but technology, if you identify a problem in technology, the next thing is to solve it after maybe some time. While in private settings, you can achieve a very high transaction speed, like 10 to the 1,000, it's more than 10 order of the 10. And the most popular frameworks that we have at the moment is that of Hyperledger Fabric and R3 Corda. So depending on the application that you have, you might use either private or public blockchain. Consensus algorithm. What is the consensus algorithm? Is the algorithm that will guarantee how the network is going to collaborate in order to approve transactions. In public blockchains, we have proof of work, like Bitcoin, or proof of stake, like in Ethereum, in which validators are chosen deterministically based on the stake they have in the system, which gives like a Poisson binomial process, and proof of capacity, another method. But in private blockchains, we usually have multi-signature approaches. What is this? You say, OK, I have these 3 nodes being responsible for agreeing that this set of transaction is valid. And why it's multi-signature? Because All three have to provide their private key in order to validate the transaction. This is the most popular way of consensus algorithm in private blockchains. Okay, this is about public and private blockchains. Now we're going to have a very fair introduction into smart contracts. So what is a smart contract? It's a relation between two or more parties, which includes legally enforceable obligations between them. And current paper-based systems drive 18 trillion in transactions per day. So if we manage to digitalize everything, that's going to give a lot of more profits. We are going to have a most cost-effective smart contracts industry. And what is a smart contract? A usual contract is something like this: a piece of paper, many inconsistencies, very hard to read. While if you encode this into a script, you have something that is easier to read. Maybe in the future it will be easier to read. At the moment, it's a piece of code. But it's something that you can upload on a chain, on a blockchain, and everybody is able to see this contract. This is like the smart contract. The process in the smart contract is to define 4 different stages. The first one is the print definition of the contract, in which you define who are the variables of interest, like terms and conditions, members, and what are the conditions to be met. Then you need to define the events that will trigger the contract to be executed. Then you need to define the method at which, when these events trigger, the contract is going to be executed. And finally, you have the settlement. Everybody agreed that the contract took place and upload this on the network. This is an example how smart contracts can improve business today. Let's say we have a ownership of a vehicle being transferred between several parties. In a traditional way, you go through this. You have the manufacturer, dealer, leasing company, lessee, and the scrap merchant, all of them having different database, and all of them need to communicate with all the others at any time in order to understand what is the current status of the action that we would like to take place. While if you use a ledger that has smart contracts facilities, you can have a setting like this in which you linearize this problem. Every node has access to real-time data, what is happening to the status of this action. Another example of blockchain technology is like initial coin offerings, as we've said. What is initial coin offerings? It's like a traditional crowdfunding campaign in which instead of asking for fiat money, you ask for cryptocurrencies. And we have many startups and enterprises going through this way. And the whole idea is that in most of the cases, instead of shares of stock, the investors are buying some tokens that are actually utility tokens. What does utility token mean? Is that the investors do not really buy this token in order to make money. It's not an investment. They buy this token because they would like to have access to the platform when it's going to be operational. So these tokens unlock access to the new platform. Let's say something like Filecoin. You have the token, which means that when the cloud infrastructure is settled up, you can use your tokens in order to store some of your data into their infrastructure. The name of ICOs was inspired by IPOs, but it's completely the reverse operation. In IPOs, you have the companies performing and then have some of their quarterly reports, and then they go public. In ICOs, they actually have a white paper, maybe an MVP in the best scenario, and they raise some money in order to start developing their product. If the product provides any ownership stake, if you see like a security token, it means that this product has to be regulated, which means that they have to satisfy all the requirements imposed by Security and Exchange Commissions of each country. How you start an ICO? Firstly, you need a white paper. You need to understand the idea. Then you need to select a framework in which you are going to generate these tokens, understand what are the type of the tokens that you are going to generate it, and then you need to offer this token at a price. The way that this is done at the moment, it's not very scientific. It's quite random how you determine the price of a token. But what companies are expecting is that after some time, due to the dynamics of the network, demand and supply, this value will surge. This is how it works. Even though now we have like a new science coming out called tokenomics, in which they study the economy of these tokens. Type of tokens, we can have utility in one, in which the token can be used to access a particular service. You don't expect any money to get any money from these utility tokens. You just use them to unlock services. securities or equities, in which the token represents stake into the company, and these tokens have to be fully regulated, and currencies. Currencies are like tokens that can be used to purchase or sell items. At the moment, we have like different retailers accepting Bitcoin and Ethereum as cryptocurrency. Formally, it's not a cryptocurrency, but if you can use it for buying things, it can be like classified informally as cryptocurrency. Risks in these initial coin offerings, we have many risks involved, like consumer, market, and technology. The most important actually ones are the technology ones. Nobody knows if there are any flaws in any of the applications that you buy, or any product, or even in the public blockchains. Market risks, we have price volatility, as you know, with cryptocurrencies, a lack of liquidity for some products. Not many people interested in buying more tokens. Possible market manipulation by people that own a lot of stake into these ICOs. Market investments attributed to ICO cash outs, exchanges not acting fairly, which we've seen many times, and exchanges with limited understanding of technology risks. And also we have consumer risks. There are no clear tax risks. There are no clear regulations. Each country has different regulations, and it's a very dynamic environment. They change very, very frequently. So, because we have this initial coin offerings technology being very, very popular, and actually it's a very effective way of, for crowdfunding, and like there are communities that would like to mitigate the risks imposed by these ICOs. We have many communities around the world trying to come up with some standards. What is a standard? It's a set of like heuristics that you can use in order to understand if an initial coin offering is a scam or something which is legit to invest on. And some questions out of the like 200 questions that have been developed by one consortium that I'm working with are like this. Firstly, you need to understand the regulatory framework in the jurisdiction where the ICO is conducted, because if they do something which is like not according to the law, it means that what you invest will disappear at some point. Do they explain why they need the amount of money? There are ICOs that are raising like 50 million, 100 million, 200 million. Do they really need this money? You need to go and investigate. Check the company's history, if there is any track record, patents, publication, or financials. Conduct background checks of core team members or advisors. Are these people real? Or just they have a fake LinkedIn profile with many, followers, and then just use this for promotion? Are there any partners or industry association related to the ICO? Is there a real need about the product or something that is really needed? Do they really need decentralization? We have many applications nowadays that decentralization is very important. For example, we live in 2018, and it's the world of data, and you have like multi-billion companies getting money out of the data that you really produced. This is their only business. Decentralization is really important there, because through decentralization, you might get also some rewards of the money that you produce for these companies, like social media or search engines or whatever. Other question, is there any code published in open source repositories such as GitHub? You go and check, audit the code, if there is any available. Is the team active in proper communication channel, or they're just ghosts that publish some post every 2-3 days? Is the team complete with respect to all important roles? You need to check this, it's very important. If they don't have any blockchain expert and they claim that they do something on blockchain, then you need to go and investigate this. And are there any escrow mechanisms in place to return the funds in case something goes wrong? Or are there any single points of failure? These are some of the most important questions that you need to worry if you are thinking to invest in ICOs. Okay, that's all about my presentation. I tried to make a very fair introduction to everything in blockchain, ICOs, and like tokenization. Thank you.
How do you define the order in which every transaction is going to be added to the blockchain?
How do you define the order?
Yeah, the order. Like you said that you hash with the previous node. How does each miner know which is the node that this new node will append to?
I don't get what you mean. So you have a clear transaction which says, I would like to transfer something to someone. 3 inputs, me, the other person, and the money. Okay?
But, 5 different miners could be working on different transactions. So how do you know which one will be the next and which will go after the one that's being calculated at the moment?
What do you really mean? You have this Merkle tree structure in which you actually check all the transactions.
Okay, but is it so at any given moment, more than one transactions are in the network waiting to be verified?
Yes, you have this block of the transactions.
What's the authority that defines the order that these new transactions will be added to the blockchain?
There is no order. You just see the timestamps of the
Okay,
transactions.
so it's based on timestamp.
Yeah.
Thank you. I was wondering, do you have any predictions or can discuss a bit about the writing on the wall with regards to the future pattern or the upcoming pattern of regulation, certification, formalized exchanges? I mean, where do you see the standardization of the industry going, especially as blockchain applies to cryptocurrencies?
Yes. Okay, currently there is a committee developed by the International Standard Organization, ISO, in which I take part, and we try to come up with a standard like, ISO 9000 or ISO 27001 or whatever, in which we try to develop some guidelines for blockchains and also cryptocurrencies and that stuff. It's an upcoming thing, yes.
So this is a good organization to follow to get
ISO.
information on, okay.
Yeah. It's the International Standard Organization.
Very good.
And
thank you.
it's the technical committee 307 that is working on this.